Hello students, welcome to this lecture number 16 on the structure of the atom. In this lecture, we are going to discuss the energy of the orbital. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. Energy of the orbital, that is found different for single electron system and the multi-electron system. Electron system. For single electron system, the energy of the orbitals only depend on the principal quantum number. So we can write this very important thing: energy of orbitals depends on the principal quantum number, that is n. Principal quantum number. That is n. This is the energy diagram for the single electron system, that is hydrogen atom. We can write this energy diagram for hydrogen. So this is the energy diagram. From this energy diagram, you can easily able to understand one thing, that the energy of the orbital only depend on the principal quantum number. And you can see one thing, that in spite of these 2s electron, 2s orbital and the 3p3 orbitals having the different shape, this is having the same energy. You can see here 2s orbital is same energy with the 2p, 3s orbital with the same energy with the 3p, 3d, 4s orbital with the same energy with the all these orbitals that is available to the cell. So there is no dependence on the azimuthal quantum number, that is L. It is only dependent on the principal quantum number. So we can write this very important thing. Here, one thing that you need to understand, that this orbital, the orbital having the same energy, it is called the degenerate orbital. So we can write this important thing, the orbital having the same energy the orbital having the same energy is called the degenerate. So here you can see 2s, 2p, 3s, 3p, 3d all are degenerate orbital. And here you can see 1s orbital having the least energy compared to the other. So when the electron in this 1s orbital, we will call the atom in the ground state. We can write another important thing, the ground state. Ground state, when the electron in the 1s orbital, that is in the lowest energy state, lowest energy level of the orbitals, that is the 1s orbital. The ground state, we can say the ground state when the electron in the 1s orbital, electron in 1s orbital is in 1s orbital. This is called the ground state. And when electron in the 2p, 2s, 3s, 3p, all this orbital, we will say this is in the excited state. So another thing that we need to understand, that is excited state. Excited state is when the electron is in the 2s orbital, 2p orbital, etc. higher, not in the 1s orbital. Then we will call it is in the excited state. So two things that you need to understand. This is ground state and another is excited state. And this, when the electron in the 1s orbital, the distance between the nucleus and the electron is least. So the attractive force between the nucleus and the electron is maximum when it is in the 1s orbital. That is why the energy of the electron is least when it is present in the 1s orbital. So we understand that energy of the orbital in hydrogen atom totally depend on the principal quantum number, not in the azimuthal quantum number. And we understand what is degenerate orbital, we understand what is ground state, and we also understand why in the 1s orbital the energy of the electron is least, because of the highly attractive forces, that is high attractive force that is in operation between the nucleus and the electron. Now we understand what is the trend in case of the multi-electron system. What is the energy of the orbitals, that we will now understand. This is for the multi-electron system, that you can easily understand the energy in case of energy of the orbital in case of multi-electron system, that not only depend on the principal quantum number but also depend on the azimuthal quantum number, that you can easily able to understand from this energy diagram. You can the energy of the orbitals, energy of orbitals in multi-electron system depend on N and S, depend on N and L. N is the principal quantum number and L is your azimuthal quantum number. That you can see the every orbitals in the subcell, in the different subcell, that is in the P, S, P, D, F, you can see that is P, D and F. You can see there is the increase of the energy. You can see 1s orbital having the less energy than the 2s orbital, 2s orbital less energy than the 2p orbital, and likewise this is going once. So we can write this important thing, that energy of the multi-electron system not only depends on the principal quantum number but also on the azimuthal quantum number. Now question arises, why it is so, why there is a difference in this type of trend between the multi-electron system and single electron system. For this we have to understand the system, what system is operating in the single electron system and what is in the multi-electron system. In the single electron system, you will see that is there only one force of interaction, that is attractive interaction, that is between the electron and the nucleus. Only things is there. But in the multi-electron system, you can see apart from this attractive interaction between the nucleus and the electron, there is the repulsive interaction. Between the electrons, there is a repulsive force going to act, and that is going to the difference, that is going to make a splitting in the same cell, different subcells having the different energy orbitals. So SPDF having that different energy in case of orbitals, with different energy in case of the multi-electron systems, and we will understand this in much deeper. So we understand one thing, that energy of the orbitals in the multi-electron system that depends not only the principal. So this is the formula. From this formula we will able to understand the energy of the orbital, how it depends on the principal quantum number and the atomic number. This is the atomic number and this is the principal quantum number, and this is this unit of this is kilojoule per mole. So you can see one thing, that as the Z is increasing, means what? Now positive charge in the nucleus goes on increasing, and it is when it is increasing, the attractive force between the nucleus and the electron goes on increasing, and this will make this energy of the electron or energy of the orbital goes on decreasing. So as the Z increases, the energy of the electron goes on decreasing, and as the N increases, the energy, it is far away from this nucleus, so it is far away, it is going to increases. So there is, because of this minus sign, you can see this type of things arises, that is when N increases. When N increases, your energy will goes on increases, because it will be less and less negative. Less negative means it will have the higher energy. More negative means it will have the lesser energy. That you have to understand. So from this point of view, we will be able to understand, as the Z increases, the energy of the orbital decreases. As the N increases, energy of the orbital increases. So this is the relation you can see. Now, when there is a positive charge, that is, here is a positive charge is there, and now this electron and this electron, the outside, this is the outside electron and this is the inner electron. What is going to happen? That is, suppose the charge of this nucleus is Ze, and this electron, the outside shell electron, will not going to experience the same charge, that is Ze, because of the shielding effect, and this is called the shielding effect. Or it is called screening effect. Due to this shielding effect or screening effect, these outside electrons will not able to experience the same positive charge as it should be. It will feel a effective charge. We can write Z effective into E, and Z effective will be always less than Z effective E is always less than ZE. So this electron will have the higher energy because of the fact there is a lesser attractive forces between this nucleus and this electron, outside set electrons. And this effect you can see also in within the cell itself. Within the cell, that is in the different subcell. You can write this in different subcell also. This screening effect is the screening effect is predominant. The screening effect is predominant in the different subcell also because of the different shapes of the orbitals. We know the s orbital having the spherical in shape, p orbital having dumbbell shaped, d orbital having the defined shapes, and due to these different shapes it will screen the positive charge of the electron in the different extent, and that is going to create different effective charge that will be experienced by the electron of the subcells. So these things let us understand. The S subcell, the orbitals in the S subcell, because of its spherical nature, it will screen, the screening effect, we can write this screening effect of S subcell because of its spherical nature is greater than the P subcell. And P subcell screening effect greater than the D subcell. So what is going to happen due to this different screening effect, screening capacity of the different subcell? So what is going to happen? The Z effective experience by this these electrons on the different subcell will going to be decreases. So when this Z effective going to be decreases, what is going to happen? There will be the different attractive force between the nucleus and the electron will be there, and this is going to create a splitting of the energy within the cell itself between the subcell orbital of the subcell, and that is the reason there is the different energy in the orbitals in the different subcells. That you can see the one is orbital having the less energy than the 2s orbital, and 2s orbital less energy, 2p orbital, 2p is less energy than the other energies, other energy in the other orbitals in the energy level. So we can see there is a different type of screening effect that is going to impact this Z effective experience by the different electrons in the orbitals, and that is the reason the multi-electron systems is having the different energy of the orbitals in the different subcell is different. That is the main reason. And now how we can able to identify this different energy level in the orbitals? For that there is a rule. This rule is called the Bohr-Bari rule, or N plus L rule, and that we understand why the multi-electron systems having the orbitals, which is depend on the energy of the orbitals depends on the N and L, because that is the screening effect, different screening effect of the different subcells, orbitals of the different subcell, because it is having the different shape. Due to its different shape, they are screening the positive charge or the electron in the different level. Now we understand the Bohr-Bari rule. Or N plus L rule. This is orbital. Suppose one s orbital, its value is n, value of the n is 1, value of the l is 0, so value of the n plus l is 1. So it will having the least energy. Then 2s orbital, its value of the n is 2, its value of the l is 0, and it is having n plus 2. So it will having the higher energy. Then 2p orbital, it is 2 and this 1, and you see this is a 3. So you can understand the why the 2p orbital higher energy than the 2s and 2p orbital. Then 3s orbital. 3s orbital, you can see this is the n value is 3 and value of the l is 0 and this is 3. See here n plus l value is same, but due to the higher n value, the 3s orbital will having the higher energy. So we can write the first rule that when n plus l value is same, then orbital having the higher n value shall have higher energy. Higher energy. So when electron going to be fielded, it will be first fielded in 2p orbitals, then it will be 3s orbitals. Now 3p orbitals, you will find 3p, 3 it is 1 and it is 4. Then 4s orbital, 4, then 3d orbital, here you can see the 4s orbital having the 4 and 3d orbital, because of the higher n plus l value, it will having the higher energy than this 4s orbital. So you can see this impact here. So in this way you can able to understand the energy of the orbitals by calculating the value of the n plus l. Where the n plus l value is same, then we have to go the higher n value, which is having the higher n value, it will have the higher energy. And in this way you can, this is the Bohr-Bari rule, that is helpful to know the energy of the orbitals. So This is all for today's video. In this video, what we have understood? We have understood the energy of the orbitals, and this energy of the orbital in the next lecture we will understand. It will be very much helpful for writing the electronic configuration of the atom, because energy of the orbitals will decide how the electron is going to be filled in different orbitals. And that is all for today's video. If you like this video, you can share to your friends, and thank you for watching, and we will meet in the next video.